Hi, my name's Jared Broad, and in this screencast we're going to be going over the iconic moving average cross trading strategy. This strategy has been around for a while and people seem to keep coming back to it. First, we're going to cover the theory of the moving average cross, and then some of the common pitfalls in its implementation. Then we're going to code up the strategy from scratch using the basic template, and then perform a sanity check on our results. Once we've got a working algorithm, we're going to tweak it a little bit to try and optimize the output. So let's dig into it. So firstly, what is the moving average cross strategy? Put simply, it's just a trending indicator, and it's one of the most simple trending indicators possible. First, you have a moving average of the prices over time, and a second, faster moving average, which uses less data samples. When one moving average crosses over the other one, it's a signal to buy or sell stock. Using this indicator, people have tried to predict the trends for a long time. Next, we're going to talk about some common pitfalls on how you implement this strategy. Firstly, when you're using numerical indicators, you need to debounce the signal to ensure you're not getting many more orders than you actually have signals. As a human, we tend to automatically average and approximate, where a computer, bound by exact precision, can sometimes send 1,000 orders when you would expect it to only send one. So here we have the 10-year view of the S&P 500, where if you zoom in, you can see locations where you wouldn't want the algorithm to trade because the signal wasn't sufficiently strong enough. Secondly, because your algorithm is running on a loop, it's easy to fire the same order over and over again by mistake. You need to make sure you only have one shot or one trigger per signal. So for example, the code below would be something you might write on the first attempt of an algorithm. If the EMA short is greater than the EMA long, then we'll just buy some stock. However, as the algorithm is running on a loop, this would mean that your algorithm would buy stock over and over and over again until you ran out of money. The better way to do this is to simply keep track of when your signal has triggered. You can do this using a Boolean and checking for it before you place your order. The last and most common mistake is overfitting. With a strategy like EMA, it's tempting to adjust the short and long moving average parameters until it optimizes the return. Adjusting these values without any foundation in reality or some foundational principle to set the values is essentially fitting your algorithm to the past performance. You'll soon find as you go to trade your algorithm live that the past performance does not reflect the future, as the markets will be continually changing. Now we're going to jump into coding the strategy from scratch. We're going to start from a basic template so you learn the most possible. First, you clone the basic template by clicking on the starter algorithm. Now we have the basic template, and I can just use Control and the arrow key to make the font larger so you guys can see it. And we can start simply by renaming the algorithm, moving average demo, so that it's a comparable strategy to the other ones that we see regularly. Let's trade it on the S&P 500. So now let's configure the initialize function to set up a testing environment while we develop the algo. We ideally don't want to test over a really long period, otherwise every test that we do to see if there's any bugs will take a very long time to get back. Let's just test it over a few months, maybe from January 1st to March 1st. Okay, and we'll test it with $30,000 cash. We'll test it with minute resolution data, and we'll run it in series mode. So in the QuantConnect IDE, you can actually run it in series or parallel mode. When you're running in series mode, you're pushing day after day of data into the same computer, the same algorithm, versus if you're running in parallel mode, you use many different computers to backtest your strategy. This is especially useful if you're doing any sort of intraday algorithm testing. So if your algorithm closes by 4 p.m. each day, you can dramatically increase the speed of your backtest, especially if you're using high resolution data. We've got the basics set up, initialized. Let's have a look at our event handlers. We have 2 event handlers here in the basic template, but you actually only need one since we're going to be using minute resolution data. So let's go ahead and delete the tick handler. And now our data is just going to be pumped into the on trade bar handler, and we can delete this template code here. We have a template set up, ready to go to write our moving average code. Firstly, it might make sense for us to define a moving average class, which is going to keep track of the moving average values and manage that all independently so that we don't have to look at it in this code. Typically, a new class is defined in a new file, so you could go up to the project menu, and on the Files tab, there's a Add New File button, and we're going to call this class the Exponential Moving Average class, and we'll add that. And once it's added, we now have this empty class for us to modify. And we'll call this the exponential moving average. Now it's in the namespace QuantConnect, so it'll automatically be accessible. And I'll just increase the font size of that one too. So with this, we're calling it the exponential moving average. And this is just going to be a simple class. So in here we want a public constructor so that we can create a new instance of the exponential moving average class. And the key parameter that we'd want to define for an EMA would be the period. How many data samples would we like this to perform an average? So we can call integer period there. And just to save this information, we could save it here. And we can also save the running value of the exponential moving average. So we create this, we go this, not period, and that's it for now. To calculate the exponential moving average, it's more efficient to do it in line. So if we find a formula for the exponential moving average, which is in line, it's much easier to do. A quick search on Wikipedia shows us this formula. So ST, which is the EMA, is equal to a multiplier times by the current price plus 1 minus this multiplier times by the previous value of the EMA. You can think about this as defining the new EMA as a fraction of the new price plus the old EMA, so that the EMA is ever so slightly adjusting over time to its new value. We need a function to accept the new values of the price. So we have this public add sample, and that price is y in this formula. So we have some constant times y, and then 1 minus that constant times the previous value of the EMA. When we add a sample, we need to update the value of the EMA. So firstly, let's handle the 0 case for when we haven't set the price of the EMA yet, so it would be 0. When you're using a running algorithm or an algorithm which updates itself over time, you always need to define the first values because it hasn't been initialized yet. So to determine if it's the first value, we can track the number of samples that we've taken, which could be an interesting debugging piece of information. So we'll track the private int samples here. We can initialize the samples to 0. And then every time we take a new sample, we just increment the sample count. If samples is 0, meaning we haven't taken any samples yet, the EMA will just be set to the price, and then we'll return the EMA. So with this add sample routine, it would be handy if when we add a sample, a price sample, we will also get back the updated value of the EMA. So let's make add sample return a decimal, and then here we'd make it return the EMA. So now for the other cases, when the samples are not 0, we can calculate the updated value of the EMA. So this is where we need the Wikipedia formula. The new value of the EMA the constant times the price, and then the different constant times the previous EMA. So for us, the constant is actually the period. You can think about it as such that if you're doing a 10 EMA, the constant times the price is 1/10 times the price plus 9/10 times the old EMA. It'll be 1/10 or 1 over period for the 10 EMA times the new price plus period minus 1 divided by period. Period minus 1 divided by period times the previous EMA. Now this is just a very quick formula. There are tidier versions of the formula which will be in the clone algorithm which you'll download, but this is just something for us to get started. And we just have an error. There we go. So it's updated. So now this will add the sample, initialize it, recalculate it, and return it. Now to access that EMA, we can't access the private variable, so let's make a public constructor. Just a simple public constructor. These are nice so that you can isolate your class code. In our script, in our main algorithm, we need to initialize an instance of the exponential moving average class. So we can do that at runtime here. And then we can use those two algorithms, those two instances. We'll actually call it the EMA fast and the EMA slow. We'll use those here. And the first thing that we really want to do is update them. So we need to push in the price. So we have the add sample method where we push in the price here and add sample. So we haven't defined price yet, but price will be something that we get from QuantConnect. And that's pushed in on this dictionary here on the on trade bar event. So the data is inside here. So the price is equal to the data, SPY, and we'll take the close from the trade bar. So inside this data, we can find our SPY trade bar and then take the close out of that trade bar. We actually define a symbol up here, which we're trading. So instead of SPY, we'll just replace that with symbol. We have exponential moving averages, which are being automatically updated and are available for us to use in our code. If we ignore all of the common implementation mistakes that we covered in the beginning, the next step would be for someone to go like this. So if EMA fast.ema is greater than the EMA slow.ema, then we will simply order some stock. Else, if the EMA fast is less than the EMA slow.ema, then we will short the stock. So we want to short the symbol or the SPY, and just for argument's sake, we'll do 100 stock. And we'll purchase 100 stock. So as you remember, this will cause every single trade bar to send an order, which would flood the system and make us go broke. So we can't do that, but just so we can do a check, we'll run a build and a backtest to see how it goes. So it builds successfully. Let's run a backtest. When we run this backtest, it's not actually doing anything, but if we go back and have a look at the EMA, there was just a small bug here. We'll define period as a decimal because we're using it in a formula and it wasn't behaving nice and returning 0. So we fix that bug and rebuild and rerun the backtest, and it should work fine this time. So now the backtest is finished and we can have a look and see what it got up to and perform a sanity check. When you code an algorithm, you just need to make sure it's doing what you actually told it to do. So firstly, it's trading, there's many orders here. There's hundreds or thousands. If we actually look at the timestamps on the order, it's trading at 9:31, 9:36, 9:37, 2 o'clock, 2:05, 2:06, many times during the day. And when people define the moving average cross strategy, typically they're talking about multiple days. So one of the things we're going to need to fix now is to make sure the algorithm uses daily data rather than just minute data. So we expected this. The other thing that we notice if we look at the trades is that it goes long, short, and then it goes short again, and then long and long again. So we covered this in the beginning. If you have the signal being triggered more than once, you can send multiple orders at a time, which isn't what you intended. You only intended it to go long or short and place one order to set the direction. So let's go back to the code and see if we can fix that. The first step to making sure that it only fires once per signal would be to monitor the holdings. So we need to know what our current holdings are and only trade when the signal says to go the opposite direction. So the holdings are in the portfolio object, and we can access that with the portfolio class here, with the symbol that we're trying to access, or SPY, and the quantity. So now we have an integer, which is the quantity of stock that we currently have. We may want to actually make our decisions based on what stock we have. So if the holdings are 0, or we don't have any stock, or the holdings are short, if the holdings are less than 0. Then, in this case, if we're short, or if we don't have any stock, then is when we probably want to go long. So now, similarly, if the holdings are 0 again, or the holdings are greater than 0, or that we're long, then we will probably want to go short. If we don't have any holdings, or if we're long, then check if the fast EMA is dipped underneath, and then if that's the case, then we can go short and order minus 100 stock. In this particular example, I'm actually going to make it a long and short strategy and not just a long only strategy. So we can adjust this now so that the quantity that we purchase is dynamic. Now we've written our strategy so that we'll set our holdings to positive 100 or negative 100. There's no in between. We'll make sure that we only fire one order per signal, so that if we currently are long, we're not going to continually purchase stock. So now we can save and run another backtest and see how it goes. So now we've run a new backtest using the updated code, and we can look at the results to see if it passes the sanity check. Firstly, it goes long and then short and long and short and long and short. It's only doing one long and one short operation at a time, which is great. That's what we wanted. And then secondly, the quantity is 100 plus and then minus 200, which would bring us to negative 100 holdings, and then positive 200 to bring us back to positive 100 holdings. So again, it looks like the quantity is working perfectly and the algorithm's bouncing around negative 100 and positive 100, which is what we wanted. The only thing that we need to update is that it looks like it's still doing the intraday trading, and we really want it to be a daily algorithm, so it only trades once per day. So we need to look at the data that's coming in and only run this analysis once per day. We currently don't have daily data. We'll add that sometime in the future, but for now it's easy enough to get around. You just need to look at the date time. We can track the date and only rerun the analysis when the day changes. So we'll just call it sampled today, which will just be a date time object. We'll update it when we update the price. We take the timestamp object, which is a date time class inside of the trade bar, and then the date component. So the sampled today is updated every time we get a new trade bar. We'll add a statement here which simply checks if today is unique, if we haven't run today yet. So if the sample date is equal to that one, then we'll return, and we'll just exit the strategy immediately. So if it's a new date, then we'll come through here and rerun the sample. Essentially, this will be running the moving average cross strategy, but just on the opening bars. Okay, so now we've run our back test using our updated daily data, and we can re-inspect the orders to make sure it passes the sanity check. So here, looking at the orders, we have one on the 21st, another on the 23rd, another on the 28th, and they're long, short, long, short. That's perfect. So it looks like the algorithm is now working on a daily data frame, and it's only taking one position per signal. It's still a little bit rough around the edges, and to keep this tutorial short, I won't polish it up here, but there's a few things you can do. For example, this exponential moving average is currently an approximation. If we add another signal here to show that it's ready, it will only return when the sample is greater than or equal to the period. What this indicates is that we have the minimum number of data points for it to be a true exponential moving average. because we wouldn't want to make trade decisions without having accurate data. We could, for example, in the event handler, we could check if the exponential moving average is ready before we actually do any trades based on that signal. Secondly, what I haven't discussed yet in this strategy is how to debounce your algorithm. This would be quite important if we were getting far more orders, but it looks like we're only getting a few, which is probably just luck. If we used a longer data set, we might see a few more erroneous errors coming in here. To debounce your signal, you might check the average price of your holdings and see how it compares to the current price, and only trade when you move some sort of fixed percentage away from that price. All of this is defined in the clone algorithm, which you can see in the university. If you click the clone algorithm button, you can bring that algorithm into your account. So now I'm going to skip over this and pull up that fully polished algorithm, and we're going to do a little experiment. So one of the core mistakes that people make with the moving average cross strategy is that if you play with it long enough, you'll get a nice looking curve. And this is because you can optimize it so that it will cross, it'll make the trades at the right moment to give you a nice curve. However, this is by definition curve fitting, and you have to be very careful when you do this, when you try and trade it on a live account, because the market very rarely continues looking how it did. We can do some experiments to practice curve fitting to know what not to do. And to do those experiments, I recommend you play with the exponential moving average values here. See, here we have 10 and 50, but if you play with those, maybe you want to experiment with 15 and 12 and 13 and a slow moving average of 100 or 200. Eventually you'll get a curve which looks very promising, but I would not recommend doing it in live. So that's all for now. I'll let you guys optimize and play with the different values for the exponential moving average. If you come up with any sort of magic combination, be sure to share it to the community and we can discuss it there. Cheers.